Hello guys, so this is the first problem from Atcoder's DP contest. In this series of videos I'm going to solve all the problems from Atcoder, which are all the dynamic programming based questions. So let's start by solving this one. The problem statement says that there are n stones and a frog is there who is initially at stone 1, so he can do two moves, like from stone 1 to he can move either to 2 or to 3. Alright, so in general from any stone I he can move to I plus 1 or I plus 2. So the cost of moving from one stone to the other one is based on the heights of these stones. So initially we are given the height of each stone as well, so the cost is absolute value of the differences of the heights. We need to find what's the minimum possible total cost incurred before the frog reaches the stone. Alright, so let's try to solve this one. Okay, so let me just remove these things first. And yeah, what all the constraints that we have: n and h1 to hn. Okay, so we have n and we have some array of size 10 raised to power 5, so we'll have 3 1 2. Let's just take the input for all of them. Will this be, I think simple integer would work. We don't need to take long or as such. Now as we know, this is a dynamic programming because we are already solving the dynamic programming ones. Let me show you how can we visualize this one. So for example, we have certain stones, alright, and these stones are having different heights. For example, this one is bigger one, or this is the, and then somebody is here on top of stone 1. So let's say this guy is there, and what he can do is he can try to make a move to this one, or he can try to make a move to this one. So at any position, let's say if there was, he somehow landed onto this particular one, but before there was some other as well, like, yeah, so at this moment if it is here, if he is here only, so he could land to this one or this one. So yeah, the basic approach that we need to follow is just try to make all the possible ways for, and like from here to here and from here to this one. Like if this is I, if this is I and this is I plus 1, so what we will try is first try to find the minimum answer that we can get by moving to I plus 1, and then the minimum answer that we can get to by moving to I plus 2. So let's try to quickly code this one. We have a certain index. If let's first find the answer equals to, it can be by moving to answer e plus 1. And what's the cost? Yeah, we need to maintain, because moving to this one is cost of h of I plus 1, that is the area of I plus 1 minus area of I plus I, that, and it should be their absolute value. So array of I dx plus 1 minus array of I dx. And then we can also get is we can also get is we will check if, because we don't want to jump from here. If we are here, we don't want to jump to stones, because if there is no more stone, so what we need to check is if it is possible to jump or not. So if I dx plus 2 is less than n, then only we are going to find answer equals to maximum of answer, the current answer that we got from the above, like from here. And let's compare it to this one, I dx plus 2, and then the cost will be array of I dx plus 2 minus the cost of the current element. and we need to memoize. So let's create a dp table as well, because at any moment we can have, let's say, we could see two different ways to land on yeah, we can have multiple occurrences of one a frog landing onto one stone. So if we have landed here sometime in the past, we should not try to calculate the best answer from a particular j. Let's say if frog somehow landed onto j, there can be multiple ways he can land onto j. So if he has landed onto j, that means if I have calculated this one already, and for the first time, if he landed onto j, then from here to move to the end we have already calculated the answer, so we will not try to recalculate it. So yeah, let me just initialize it with the main set dp of -1 size dp, and the base condition would be if idx reaches the last stone, that should be the last stone is -1, then we just need to return. If this itself is the last one, that we don't have to move anything at all. All right, and if that's not the case, we need to find the answer, and we also check if this is already calculated or not. If this is already calculated, then we can return that answer as well itself, otherwise we need to return the answer. All right, so let's just print this one, solve 0. Initially it is at the 0th stone. Let's see if it runs. So we are getting, all right, it says something is wrong. Okay, n is not declared there, so it was complaining about it. All right, okay, somehow it is already showing 0 without having, okay, we're not taking n as input. So let's now try to test our code with the, so it says 50, however the cost is 30 is the better answer. What's wrong? Let's find it out. So if we reach the current index itself is the last one, we should return 0. That's correct. If that's not the case, we need to find the best answer. Best answer would either be from the next one if we can reach, that means by making a move 1. all right, otherwise the best answer would be by making move 2. all right, so yeah, I think the problem is here. We needed the minimum answer instead of the maximum. So let's now try and check if this works. Think should work now. Yeah, it works. And if we take some other example, let's say for example this one, this gives 40. That's correct. Let's try to submit and see if it works. All right, so I'll upload the link to my solution so that we can check this. Okay, so this is running. all right, so it passed. So yeah, that was quite easy. In the next video I'll try to solve the problem B. So yeah, thanks for watching this video, guys. I hope you enjoyed it.